In the year 2013, a team of archaeologists digging near a set of ancient sea caves on the Red Sea coast of Egypt found something nobody expected: a papyrus diary. Not a myth, not a carving, an actual logbook, written in the hand of a real man named Mir, describing his real job. And his job was moving stone to the Great Pyramid. That single discovery did more to explain how the pyramids were built than a century of speculation, and yet most people have never heard of it. So today we are going to walk through what the evidence, the actual physical evidence, tells us about how a Bronze Age society with copper tools and no-wheeled carts built a structure so precise that in places you cannot slide a piece of paper between its stones. No aliens, no lost super civilization, no secret vanished technology. Just people, and a level of planning, mathematics, and organization that we have consistently underestimated. Let's start with the scale of the problem, because it is worth sitting with for a moment. The Great Pyramid of Giza contains somewhere around 2 million individual blocks of stone, some weighing as little as 2 tons, some weighing 60 tons or more. It was built in roughly 20 years, during the reign of the pharaoh Khufu, around 2560 BCE. Do the arithmetic and that means, on average, a block had to be quarried, moved, and set in place every few minutes of every working day for 2 decades straight. That is not a task you solve with brute force alone. You solve it with logistics. And logistics is exactly what the Mir diary shows us in astonishing detail. Mir was a mid-level official, something like a project foreman, who commanded a crew of about 40 men and a small fleet of boats. His journal, written in hieratic script on papyrus, records his day-to-day work almost like a modern timesheet. He notes the days his team spent quarrying limestone at Tura, on the east bank of the Nile. He notes the days spent loading it onto boats. He notes the days spent sailing it up a canal system to the Giza plateau itself. He even complains, in the way workers have complained in every era of human history, about supply shortages and difficult superiors. This is not myth. This is a receipt. It tells us that the Egyptians had built an actual canal network connecting the Nile to the base of the pyramid, so that instead of dragging every stone for miles across open desert, much of the heaviest material could be floated most of the way by water, which is dramatically more efficient than hauling it overland. That single discovery reshaped how archaeologists think about the entire project, because it confirmed something they had suspected, but never proven, that the construction of the pyramids depended as much on civil engineering, canals, harbors and ramps, as it did on raw manpower. And once you start looking at Giza with that lens, more of the picture falls into place. Excavations at the nearby workers' town, sometimes called the lost city of the pyramid builders, found bakeries capable of producing thousands of loaves of bread a day, breweries producing beer by the vat, and butchery sites processing enough cattle, sheep, and goat to feed thousands of people a substantial protein-rich diet. This was not a starvation labor camp. Whoever built the pyramids was eating better than most peasant farmers of the period. The skeletal remains recovered from the workers' cemetery tell a similar story. Archaeologists have found bones with healed fractures, evidence of broken limbs that were set and cared for rather than the person being left to die or discarded. That kind of medical attention is not what you give to disposable slave labor. It is what you give to a workforce you consider valuable, skilled, and worth retaining. And this fits with something else the archaeological record shows us clearly. The workers organized themselves into named crews, teams that carved their own nicknames into the stone blocks they moved, phrases that translate to things like the Friends of Khufu, or the Drunkards of Menkaure, graffiti left by men who took pride in their work and never expected anyone thousands of years later to read it. People do not carve jokes and team names into stone when they are being whipped into submission. They do it when they belong to something. So we know who built the pyramids, and we know they were fed, housed, organized, and cared for. The much harder question, the one that keeps coming up in comment sections and documentaries, is how they achieved such extraordinary precision using what looks, on the surface, like extremely primitive tools. The Great Pyramid's base is level to within about 2 centimeters, across a footprint of over 200 meters on each side. Its 4 sides are oriented to true north with an accuracy of a few arc-minutes, which is startlingly close to what a modern surveyor could achieve. For a long time, this precision was treated as almost mystical, as though it could only be explained by something outside normal human capability. But when engineers and Egyptologists actually reconstructed the methods available at the time, the mystery started to shrink. Take leveling first. The Egyptians did not need lasers to make a surface flat. They had water, and water finds its own level with perfect reliability every single time, for free, using nothing but gravity. Archaeologists have found evidence consistent with shallow trenches cut around the perimeter of the pyramid's foundation, which would have been filled with water to establish a uniform reference height, after which the trenches were drained and the rock between them cut down to match. It is a method so simple a child could understand the physics of it, and so accurate that it produces results modern engineers still respect. Combine that with wooden squares to check right angles and plumb bobs, a stone or metal weight hung from a cord, to establish true vertical, and you already have the basic toolkit needed for a startlingly flat, startlingly square foundation, achieved through patient, repeated measurement rather than any exotic technology. Now take the alignment to true north, which is often presented as the single hardest thing to explain. Ancient Egyptian astronomers were skilled, careful observers of the night sky, and they had a method available to them that modern experimental archaeologists have successfully replicated. By observing 2 circumpolar stars, stars that never dip below the horizon as they circle the celestial pole, and marking the points on the horizon where a plumb line intersected each star, as it rose and set, a surveyor could locate true north by bisecting the angle between those 2 points. Run this observation over a full night, cross-check it against multiple stars, average out small errors, and you can reach the kind of accuracy the Great Pyramid actually displays. It requires patience and careful record-keeping, not equipment beyond what the era possessed. In fact, the small, consistent errors we do see in the pyramid's alignment, tiny rotational discrepancies that show up across multiple pyramids built in the same period, are themselves a clue, because they match the kind of drift you would expect from a stellar alignment method, not from some mysterious perfect technology. An imperfect but very good method, applied by skilled people, produces exactly this kind of result. Then there is the question of moving stones that weigh as much as a loaded truck, using nothing but human muscle, wood, and rope. This sounds impossible until you actually test it, and people have tested it. In 2014, physicists studying ancient Egyptian art noticed something interesting in a tomb painting showing workers dragging a massive stone statue on a sledge, with one man standing at the front of the sledge pouring water onto the sand just ahead of it. That detail seemed decorative until researchers ran laboratory experiments and discovered that wetting sand to the right degree can cut the friction on a sledge by roughly half, because the water creates surface tension between the sand grains, stiffening the ground just enough to stop the sledge from digging a trench in front of itself. The Egyptians had apparently discovered, through trial and error, a genuine piece of applied physics, one we only rediscovered and explained with modern instruments 5,000 years later. That is not evidence of a lost advanced civilization. It is evidence of an old civilization that was extremely good at observing the physical world and passing down practical knowledge. As for actually lifting the blocks course by course to a height of nearly 150 meters, the honest answer is that we do not have one single confirmed method, and there may not have been just one. What we do have is physical evidence for ramps, including a genuinely remarkable discovery made in 2018 at an ancient quarry called Hatnub, southeast of Giza, roughly contemporary with the Great Pyramid's construction. Archaeologists found the remains of a steep ramp flanked on either side by staircases with regularly spaced post holes, which appear to have anchored wooden posts used with ropes to help haul heavy loads up the slope, essentially a system of levers and pullers built directly into the ramp architecture, rather than relying on manpower alone dragging a sledge up an incline. It is the first physical proof we have of a specific, engineered lifting system from this exact period, and it strongly supports the idea that the Egyptians used combinations of ramps, levers, and counterweighted hauling systems, refined and adapted for different stages of construction, rather than one simple technique used the whole way up. It's also worth being honest about what we still don't know for certain. Egyptologists genuinely debate the exact configuration of ramps used on the Great Pyramid itself, whether it was a single straight ramp, a ramp that wrapped around the exterior, or some internal ramp system, because the pyramid's outer casing stones were stripped away centuries ago for other building projects, erasing much of the direct evidence. That is a real, open question, and reputable researchers argue about it in academic journals to this day. But an open question about the specific mechanics of one construction phase is a completely different thing from claiming the entire achievement is inexplicable. We are missing some details of exactly how, we are not missing evidence of who, why, or with what general toolkit. It's worth addressing directly why claims about hidden Earth measurements, secret geometric constants, or lost prehistoric civilizations keep circulating, because they are popular and they sound compelling. The honest explanation is that if you take a large, complex object with hundreds of measurable dimensions, and you are willing to multiply, divide, and round those numbers freely, you will always be able to find some combination that appears to match some other number you find meaningful, whether that's the speed of light, the distance to the moon, or the circumference of the Earth. Mathematicians call this the problem of overfitting, or more informally, numerology. With enough numbers and enough freedom to manipulate them, coincidental matches are not just possible, they are statistically guaranteed. None of this requires the ancient Egyptians to have possessed satellite-era knowledge of the planet's exact shape. It requires nothing more than a very large building and a person afterward willing to search hard enough for a pattern. What actually deserves our awe, and it is genuine awe, is not a mystery that requires aliens or Atlantis to solve. It's the reality of what a Bronze Age state accomplished through organization alone. Egypt in Khufu's reign had a functioning central government capable of levying grain taxes across the whole Nile Valley, feeding and housing a rotating workforce of thousands, running supply chains that stretched hundreds of kilometers, maintaining specialist teams of surveyors, quarrymen, carpenters, and stonemasons, and coordinating all of it without paper spreadsheets, without wheeled transport, using scribes, boats, and an extraordinary institutional memory carried across a 20-year project. That is the actual achievement. It doesn't need embellishment. A government that could plan and execute something on this scale, entirely with Bronze Age technology, deserves more credit for what it really did, not less credit dressed up as a mystery. None of this means every question about ancient Egypt is settled. Archaeology is a living field, and new discoveries, like the Mir papyrus in 2013, or the Hat-Nub ramp in 2018, keep refining and sometimes overturning what we thought we knew. That's exactly how good history should work, not by clinging to a fixed textbook story, and not by reaching for the most dramatic unproven explanation either, but by following where verified evidence actually leads, and being honest about the gaps that remain. The story of the pyramids, the real one, is a story about human beings. A diary-keeping foreman named Mir, workers who joked and named their crews, engineers who understood water levels and star sightings, and wet sand, and a government able to marshal all of it toward a single almost incomprehensible goal. That is a far more interesting story than we don't know, so it must have been something else. It's proof of exactly how capable ordinary people, organized well, have always been.